movies and physics don't really go well together. You loved the first video, so here is another one about bad physics in movies. First, we have the claim that space is cold. Well, saying that is really wrong, because space is a vacuum. There is no air in there to trap heat like an atmosphere. So instead of staying warm or cold the way things do on Earth, objects in space heat up or cool down by radiation. That means anything facing the sun will be scorched, while anything in the shade will get really cold. After that, we have fire in space. Unlike what some movies might depict, there is no fire in space, at least in the traditional sense, because space has no oxygen. Explosions, however, can still occur. Spacecrafts carry their own oxidizers like in rocket fuel, which contains chemicals that react together without needing external oxygen. So if some pressurized tank ruptures, an explosion would create an expanding cloud of gases that would likely move at supersonic speeds and impact anything in its path. The debris from the explosion would reach very high velocities, and with no gravity to pull them to the ground and no air drag to slow them down, the debris would travel in straight lines forever until they hit something. Next, we have guns not working in space. Well, they will work just fine because modern firearms contain their own oxidizer in the primer and gunpowder, creating a self-contained reaction that doesn't need external oxygen. The bullet would actually travel farther and straighter without air resistance to slow it down. Guns even work underwater, though with severely limited range. When fired, the bullet still propels forward because of the contained explosion in the cartridge, but water is about 800 times denser than air, creating massive drag that quickly slows bullets down. Specialized underwater weapons like spear guns are designed to specifically overcome this resistance. After that, we have acids melting everything within seconds. Even though strong acids do corrode a lot of materials, the process is usually much slower than depicted. For example, dissolving a you-know-what would take hours or even days, not seconds. Plus, acids don't melt everything. Many materials like glass or certain plastics resist common acids. In Breaking Bad, Walter White uses hydrofluoric acid, and even though he tells Jesse to specifically acquire polyethylene because it doesn't react with the acid, Jesse ignores this, which results in a catastrophe. Last one on this video, we have humanoid giants, which really defy physics in every way because of the square cube law, meaning as things get bigger, their volume is cubing while the surface area is squaring. In other words, the volume will be much larger in comparison. An ant can lift 50 times its weight, but if we were to enlarge it, it will completely crumble because its legs will become unable to lift it, and its bodily functions will stop working because not enough oxygen is being delivered by the original methods. The larger an organism gets, the more strength to weight ratio diminishes. Bones would need exponentially thicker proportions and muscles would need completely different arrangements. In other words, giants may exist, but they will look nothing like humans. They would need elephant-like legs, vastly different systems, and likely couldn't stand upright like we do.